Hey everybody, this is Larry, this is Mega Q3 of the weekly contest 446, Find XY, you have a way 1. Hit the like button, hit the subscribe button, join me in Discord, let me know what you think about this one. This one I took a little bit of a long time on. Honestly, I didn't really have a great jumping point on this one. I thought that, well, first of all, the first thing to notice is that, well, n is big enough for n squared, which means, no DP, or at least not, sorry. I didn't think there'll be an n squared dp, is what I mean to say. And k is small, curiously, so I thought, okay, well, k is only 5. And honestly, initially, I thought maybe I can figure out how to do the math, right? And what do I mean by that? Well, if k is equal to 1, that's just the number of subarrays, straightforward. If k is equal to 2, it is just you could just kind of do the case analysis of when you see an even number, right? But then it gets tricky with 3, 4, and 5, so then I kind of was trying to think about how to do it another way. I think the first thing to notice for me, and this is something that I talk about a lot when I talk about dynamic programming, I try to anyway, but it doesn't actually come up that often, which is that for each state, you do not always return one constant value, right? It just has to return the same value for you to memorize. Of course, there's probably DP version of this, but that's basically the idea, right? And as a result, I voted dynamic programming this way. So yeah, the first idea here is that, yeah, we keep track of the index, which is just 0 to n, and remainder, which is 0 to k. And this assumes that assuming that we already removed the prefix, get the total amount of each, what do they call it? X value, is it? X value for each suffix, right? For each suffix removal, kind of. And the way to think about this is that if you kind of want to visualize this, right? And let me kind of bring up the drawing things a little bit. I think the key thing is just being able to visualize this in any way, really, but hopefully in a good way, right? The idea here is that, okay, so let's say we have some array, right? And here we're doing we're starting from, say, I don't know, it doesn't really matter here, right? So then now this just depends on this subarray, which depends on this, and so forth, right? But of course, what we want is actually a subarray, so that means that we actually want the total of stuff that's here, 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 and so forth, right? So yeah, so you want the answer to all these things in a summed up kind of way, which is represented by k different numbers, actually, right? Because you want it to be 0 mod k, 1 mod k, 2 mod k, dot dot dot, right? So basically you want all these answers. That's the way that I would visualize this for this node, right? For this left edge, this index, we want all these, the summary of all these answers, right? And of course, if you think about it, then here, this is, you can represent this as a function of this thing, which is the next index, by, well, this is just no node, but just this subarray, this subarray, this subarray. I'm writing a little bit on top so I don't have, right? So basically it is on top of these, but then you add these components, right? So that's really the idea behind dynamic programming and how this kind of thing. And of course, if you kind of do it this particular way, it's going to be n squared because there are n different lines. But that's what I mean by summary, right? What I mean by summary is that you don't actually need to get these. You don't actually have to get the count of these things. Just just the count. I mean, you don't have to get. Sorry, you just have to get the count of like you could compress it into the results, right? So instead of saying, okay, maybe this one is 0 mod k, this one's 1, this one is 0, this one's 2 dot 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 with, you know, k is 0 to 4, say, you just compress this into, say, 2 zeros. Yeah, okay, that's actually terrible. I need more spacing. 2 zeros, 1 ones, 1 twos, and 1 3, right? And then you just kind of keep on passing it up. And it is something that does not come up that often, so it may be a little bit tricky. But I do say this a lot, where when I do the analysis on the complexity, I would, and we'll go over the code real quick, but the time complexity is often, and I've been a little bit lazy, honestly, recently, because I've been saying this so much in years past, but the time complexity is just a number of states times time per state, right? And space complexity is the same, right? It's number of states times space per state. The only thing that is often is that the space per state part is going to be O of 1, and then we just kind of be like, ooh, okay, so then it's just the number of states, maybe without the dancing. That's when you're weird like me. But right, and then for this particular part, right, and we could go over it. Yeah. The time complexity is the number of states. Well, the number of states we have n times k. I mean, maybe you could do a little bit tighter. I don't think so, though. And then time per state. This is actually O of k, right? I mean, it's very well hidden, but this returns k elements in an array, sure. But then we do a copy. The reason why we have to do a copy is because, well, you have to return a copy anyway, because either that or you return it by value, or by reference or by value. If you return it by value, then you make a copy somewhere, or even if you don't do explicit, but here we return it by reference. In fact, we kind of memorize by reference, which is very dangerous, which is why you have to make a copy so that you don't change the underlying thing. It doesn't mean anything to you. You can just think of this as, but you have to, you know, basically copy over the thing before you modify it. Otherwise, all your memory just kind of looked at the same place, right? Another way that you can think about this is just that you can, for something like this, right? Maybe that's a little bit cleaner, or cleaner to read in any other case. But yeah, but basically you just kind of, or even set it. You don't have to increment it. Ooh, this is actually pretty bad. You know, but okay, that's actually submitted in case I have some additional typos, right? But it should be right. It's just that this is actually even slower. But yeah. But anyway, my point there is that time per state is O of k times, right? So the complexity would be O of n times k squared, which for k is 0 to 5, you know, it's going to be good enough. And space complexity is actually not that bad to analyze, right? It's the same thing. This is O of k space because from this, and so it is the same thing, right? Which is fine. You just have to know that it is a thing. And as soon as you do, this is fine. And just to kind of go, and I did get a wrong answer, but on a silly thing. This assumes that we already removed the prefix, by the way. So this is why we have an additional for loop to kind of kick it off so that we can start by each index. But yeah, basically the function, depending on these two, we get the suffix, right? So this is the suffix answer for each suffix removal, and then you also kind of go, okay, well, this is the, if we end the subarray here, what is the remainder? So that's basically how I got how this comes from. But then, and this is, if you end the subarray further, those are all the answers that you're gonna get, which is, and you just copy over, and then you just add one for the remainder here, right? If you end here. So that's basically the idea behind this thing. And I just also want to bring up that I do initially mod k, and I got a wrong answer because, oh yeah, so index plus 1 is just index plus 1. And if you have a remainder, remember that you're doing a subarray product, which is why you have a remainder times the current number, mod k. And I just forgot mod k for some reason. I don't know. I'm being dumb today for one wrong answer, one easy wrong answer, but not a big deal. I mean, I think getting the core idea is the big part. And here, this is just, again, to kick off the first element, the first index of, okay, well, we kick off with this as the quote unquote remainder because it's one item and then that's it. And then here for each item that we get from this, we just sum it up. And that's it. That's all I have for this one. Let me know what you think. The timing complexity is already here. And yeah, make it slightly smaller so you could see it all on the same screen. And yeah. I did struggle a little bit with this during the contest, so definitely if you want to watch me solve it live next, you could check that out and kind of see where I came up with this. And yeah, thanks for watching, and you could watch me solve it live during the contest now. Okay, pretty okay. Pretty confusing one actually to read. Okay. This is a 5-pointer. I didn't look at the leaderboard yet, just looking at the scores. But anyway, all right. Positive integer nums and a positive integer k. Okay. Ones on nums where you try non-overlapping prefix and suffix from nums such that nums remain non-empty. Okay, fine. So you just take a sub array in the middle is what they're saying. You need to find the x value of nums which is the number of ways to perform this operation so that the product of the remainder leaves. Come on, this is such a long sentence. You need to find x value of nums, which is the number of ways to perform this operation so that the product of the remaining elements leaves a remainder of x when divided by k, of course. Return an array result of size k where result x is out, so you actually enumerate over all the k's. Okay. For x is equal to 0, what does x mean? Again, leaves a remainder. Oh. So we have given k, we want to do. Okay. Assume that n is too big. Yep, n is big, but k is equal to 5 is interesting. Huh. So we remove those, so we want to find the stuff in the middle, right? Is that right? The product. This one is a weird one for sure. So k is equal to 5 really begs for a case study. If k is equal to 1, what does that mean? If k is equal to 1, that means every subarray, so it's like I can choose 2, right? Give or take. It's like n plus 1 choose 2 actually, I think. For the number of... No, it has to be non-empty. No, that's why it's n plus 1 choose 2, right? I hope I get this one right. It's so easy to mess up. Oh, whoops. I mean... So 1 is going to be 1. 2 should be 3, right? And then 3 should be 6. Okay, I think that's right then. Okay. It's not hard, but it's also not easy. K is equal to 2. What is k is equal to 2? Means that as long as you have one even number, but Can I be a little bit better than this? Or is it just case analysis? Okay, so basically you have to remove all the even numbers, so it's going to be the first even and the last even. But can I, that's still like hard to think, right? Yeah, okay. This is also useless, the leaderboard. Because people just cheat. I mean, the first thing we should do is and then now it's going to be, is there Python index, right? First, how about last index? Oh, negative. Right, and then now if they're all ones and they're all odd, then it will be 0. Everything in between. So the only way you have 1 is the degree of freedom, which is maybe something like that. Still not happy about this though. I feel like this is so prone to error, even if I get this one right somehow. And I feel like this is one of those, like, I'm gonna have 5 wrong answers. Is there a DP solution? Am I overthinking this? Or underthinking it in this case? Let's see. With k is equal to 3, if you have 1, 2, I mean, if you have 1s and 2s, you'll never get into it. But how do you, 2 times 2 is 4, so it gets into 1, so it's not the number of 2s. But then how do you do a, yeah, you need to do some sort of sliding window prefix thing, maybe? Okay, so the prefix, okay, let's think about this one first. Okay, the prefix is right? Then we have to count the number of 1s and 2s, because previous 2s probably mix it into 1 or something like that, because it's divide, right? Is it DP? Trying to think about it from prefix sum, but it doesn't seem that easy. Maybe I could do, what would DP look like, right? So here, so we go, okay, so we start from I, right? We already started. I guess it's the state, right? So we have a remainder. And then we just, okay, maybe, okay, so we have a index. And then that's it, right? Is that it? I think that's it. And the key thing is that we actually return all the things, right? Maybe we don't need to do the other part. Okay. I think the case so that we can just return at most 5 elements. So it's going to do. Let's just say times k, right? So current of remainder, and then we return current. And then now we go index plus 1 remainder times num sub index, right? And then okay, so then further is equal to this, right? And then now we want to copy it, so current is equal to, so we don't pollute. And then something like this. Num sub I, but maybe this is I plus 1 actually. Mod k, which we already did anyway. So then and maybe this doesn't need to be k equals 5. Probably doesn't even need it for the other ones, but I want to audit it real quick. 924 18120. Okay, 96 is the other one, so maybe we could get rid of this. Maybe win this. Yeah, okay. Am I happy? Let's at least have one case where nums is equal to 1 times 10 to the 5th. Let's at least run this once or a couple of times as it turns out. Okay, that looks fast enough. Do I have to mod or anything? No, okay. Well, YOLO. Oh man, come on, Larry. What a silly mistake. That is just a silly mistake. I mean, that's probably fine. I think it's for this part I was stuck on whether I had to shift and add, and then I just forgot about the mod k. Come on, Larry. Come on, Larry. Okay. I mean, that wasn't that bad actually, honestly. It wasn't so good, and this has to update soon, but that's fine. Wasn't Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about today's problem, or this contest, everything in between. Stay good, stay healthy, good mental health. I'll see y'all later and take care. Bye-bye.